On this example, we're told that we need to specifically use the limit definition of derivative to find the instantaneous rate of change of this quadratic function at this specific value of x, so when x equals 1. So what I've done is I've gone ahead and listed out the derivative formula, the limit definition in here is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So as we take a look at this, what I'm going to do is I'm going to go with the general form of the derivative first, and then we'll substitute in that x value of 1. All right, you do have the option that you could start out at the beginning because we only care about that one specific value of x. We could put a 1 in where this x is and a 1 in where this x is. I'm just choosing to go ahead and get the general form first, and then we'll substitute that x equals 1 in at the end. All right, so as we get going on this, f prime of x is going to be the limit as h approaches 0. And then I'm going to go ahead and write this all out. All right, so the first thing we need to do is we need to plug in x plus h in for each one of these x's. So it's going to replace this x, and it's going to replace this x here, because those x's in the original formula are kind of placeholders. So it's going to be 3, and then we have 7 times an x plus 4. So to get us started out, remember we said x plus h is going to go in for each one of these x's. So x plus h goes in here, and x plus h goes in here, replacing each one of these x's as we get started. Next, what we want to do is we want to subtract the original formula, all right, the original function. So it's subtract, bring along our subtraction sign, but you have to be careful here. Where most students make their mistakes is they don't put parentheses around the original formula. So basically what we're going to do is we're going to cut and paste the right-hand side of that original function. So we're going to put 3x squared plus 7x plus 4. And then this is still all over our h. Okay, from here, it's a lot of algebra and just simplifying down. Hopefully not going to be too bad, but this is going to be the limit as h approaches 0. Bring along all of this. We're going to expand everything out. So the first thing I want to think about is if I have 2 copies of that x plus h, because that's what our exponent means, we have to multiply that out. And I'm going to go ahead and bring along the 3. And as we think about multiplying it out, we're going to go first, outer, inner, last, or the distributive property. So we get x times x makes x squared. The outer will be x times h, and the inner will be an x times h. So I'm going to say 2xh's. And then finally, the last will be h times h. So that'll be an h squared. All right, this 7, I'm going to go ahead and distribute to clear out that set of parentheses. So in that case, we're going to get plus 7x plus 7h. We'll bring along the plus 4. And then we also have to be careful over here where we have our negative out in front of our original function. That's like a -1 needs to be distributed to each one of these terms as well to get rid of that set of parentheses. So that's going to switch the sign on each one of those terms. So that's going to make it minus 3x squared, minus 7x, and minus 4. That's all over h. Okay. At this point, we could start combining like terms if we wanted to, or we could distribute that 3 out in front. I'm going to choose to distribute the 3, although there's nothing wrong with beginning to combine like terms to simplify the numerator. All right, so what I mean by distribute that 3, this 3 is going to be multiplied by each one of these terms inside the parentheses to get rid of our parentheses. So that's going to make it 3x squareds plus 6xh's plus 3h squareds. And then really I'm just copying down all the other terms in our numerator. Still over h. All right, at this point I'm going to go ahead and choose to combine like terms to further simplify. So let's think about what do we have as like terms in our numerator. All right, it looks like we have a positive 3x squared and a negative 3x squared. So as we combine those together, we get 0x squared, so we can eliminate that term. We have plus 7x minus 7x. So those will combine to make 0. Let me look back. I did not copy this term down right, did I? All right, let's be careful. That was a 7h. It needs to be a 7h here still. All right. Yeah. Believe me, I've made more math mistakes than you ever will in your life. All right, next up, one more like term I think we have plus 4 and we have minus 4, or plus 4 minus 4. So those will combine together and make 0 as a constant. All right, next let's copy down what we still have remaining. All right, what didn't get canceled out, we have 6xh, we have plus 3h squareds, we have plus 7h, and then we still have an h in our denominator. Okay, well, remember the big payoff here is eventually we want to plug in 0 for each one of our h's. But if we did that for each one of our h's in the numerator and each one of the h's in the denominator at this point, we'd get 0 over 0. But that's okay. What that means is that we're going to have a common factor from all of our terms in the numerator. They each have an h. And you'll notice as you get going on these limit definitions that this is kind of the process. So we want to get to this point where all the terms in the numerator have an h, so we can factor out that common factor from each one of them. So if we remove an h from the 6xh, that's going to leave us a 6x as our first term. If we remove an h from the plus 3h squared, we still have 3h. And if we remove an h from the plus 7h, we get a plus 7. All right, but that's good because at this point, we now have an h multiplied by the entire numerator and an h multiplied by the entire denominator, so h over h makes a 1. Okay, so we have limit as h approaches 0, and then we still have 6x plus 3h plus 7. But we've eliminated that problem where if we put a 0 in, we get 0 in the denominator. So what we do for finishing this up is we're going to replace our only remaining h with a 0, and we'll get 6x plus 3 times 0 plus 7 is going to be 6x plus 7. And remember, that's our derivative. So f prime of x, the general derivative here, not at a specific value of x, is going to be 6x plus 7. But on ours, we were actually asked for the instantaneous rate of change at this very specific value, x equals 1. So to finish this up, we're going to take x equals 1, and we're going to plug it into our derivative. We're going to get f prime of 1 is 6 times 1 plus 7. It's going to work out to be 6 plus 7, which is 13. And that's exactly what we're looking for, the instantaneous rate of change of this quadratic function at that specific value of x. Now, I went through it with the general form with x's involved the whole way through. Again, if all you care about is x equals 1, you could have put a 1 in where each of the x's was from the very beginning. Either way, it's basically the same amount of math algebra to go through as you work through your steps. So hope this helps out. Good luck as you're working on the limit definition of derivative.